Alright, so this is the next chapter in your engineering mechanics, which is now under dynamics. So we are learning dynamics on motion, what's driving the motion, and we have solved kinematics. We have solved kinetics using F is equal to ma formula from the Newton's second law. Now we're going to be solving it using another method. So the topic is still on kinetics of particles. So when you're solving kinetics, you are solving forces and also motion, but using a different method, which is work and energy. So before we go into work and energy, we need to have some basic understanding on something called power and also efficiency. So this is probably something that you have learned before. So there is something called work. So work is basically force times displacement, and you can put the unit of work in terms of joule. So it's basically force times displacement, or S, F times S. So in order to get power, you need to divide it with time. So power is equivalent to work divided by time. So the unit will be joule per second. So power also you can get, if you replace this one into here, you're gonna get force times displacement over time. So other than the unit of joule per seconds, you can also use watt. So basically the power the formula for power becomes force displacement over time, and the unit is watt. So other than that, if you look at this portion, there is S over T. So S over T is basically this one. V is equal to S over T. Right? You still remember? Or something like this. ds over dt is equal to V. So S over T is basically velocity. So power of a system can also be represented as force immediately times velocity. So this is power. So when you have power, we can also measure its efficiency. So an efficiency of a system, you have to measure. So typically it's using this depiction, which is output. Output is what you get divided by the input. Input is what you give, right? If you give 100% for this course, this is what you give, This is what you give. You give 100% for this course, and then you get 95% as your output from this course results. So you are working at divide 95 divide by 100. That is the efficiency of you in this course. So you're gonna get 0.95. So that is the efficiency. The maximum you're gonna get for any efficiency, sometimes it's depicted like this, or sometimes E. The maximum is 1 lah. So depending on your systems. So let's take a look at a few systems which you can easily solve because you have the knowledge. For example, this one, you've got this cable right here. So this is like 2 tension, remember? T and T. Okay, never mind. So let's check it out. Efficiency is 0.5. So remember, it is output over input. Output what? Power input. You're gonna get 0.85. Determine the power that must be supplied. So if it is supplied, it is this one lah, power input to the motor to lift the 375 Newton crate C. So this thing weighs, what does it weigh? 375 Newton. So 375 meaning it's already mg. At the instant point P on the cable has an acceleration of 1.2 meter per second squared. This is the acceleration. Oh no. Okay, acceleration here P. This is the acceleration, which is A P is equal to 1.2 meter per second squared. So if you look here, kalau sini AP 1.2 meter per second squared, this box is not travelling up. AC, this is C. AC is not 1.2 meter per second squared. It's actually twice slower. So AC is actually travelling at 0.6 meter per second squared. But you know the point lah. And the cable has velocity and a velocity of 0.6 meter per second. So velocity dekat P velocity at P of 0.6 meter per second. So kalau kat sini 0.6 meter per second, dekat sini VC is actually 0.3 meter per second. It is twice slower. Okay, so apa nak cari? Determine the power that must be supplied. Berapakah power yang kena bagi dekat motor ni? Motor power. What is it? What is the motor's power? Okay. So obviously we gotta find motor punya power So power sama dengan force kali velocity. Kalau nak cari motor punya power, meaning force dekat motor dan velocity dekat motor. Oh, that's the thing lah. That's how you get power at the motor. You have to solve it at the source. So all this information is good, it's correct, but it is not actually at the source. You got to solve it at the source. So one thing we know, acceleration is equal to 1.2 meter per second squared, velocity is 0.6. Okay, so velocity dapat dah 0.6 meter per second done. Power, how much is power? Yeah, obviously you got to solve the free body diagram. So let's solve. This is the box. Going up is actually 2T because of these two cables. Going down is actually 375. This box is actually going up. So A going up is actually positive. Okay. A going up is actually positive. Anything else? Is there anything else? Nothing else. Summation Fy is equal to MAY. 2T naik atas is positive minus 375. 2T minus 375 Newton is equal to MAY. MAY. Okay. This A is actually, you have to use, okay, you have to use this one lah. The cables. 2T, no, this has to be used. This is the acceleration of the box, okay? This is acceleration of the box. Because what? You're solving the box. So, instant point P has cable acceleration is 1.2. This one you have to use 0.6 meter per second squared. So, what can we get from here? 2T minus 375 is equal to mass. Mass kotak ni berapa? Use this formula. So mass sama dengan 375 divided by 9.81. 375 divided by 9.81 kali dengan berapa? Acceleration of the box, which is 0.6. So berapakah T? Use your calculator. Hmm. 375 times 9.81 times 0.6 plus 375 divided by 2. Hold on. 375 divided by 9.81 times 0.6 plus 375 divided by 2. 198.9. 198.9. Yeah, similar to this one lah, which is 199 Newton. Okay, so what do we know? Power berapa? Power input. So this one we know already lah, 199. So it's actually 199 kali 0.6. Berapa? 199 kali 0.6. 119.4. 119.4 watt. This is what's required. This is the output. So the output power is actually 119.4. So power input is equivalent to output divided by 0.85. So dapat berapa? So 119.4 divided by 0.85 dapat 119.4 divide 0.85, 140 watt. So you got to supply more in order to do a job which requires 119.4. you need to supply 140 watt. So let's check. Yeah, correct. 140 watt. So what you supply, you don't get all what you supply. You don't get all. You have a lot of losses. So let's look at our losses. In order to look at losses, you got to look at the system. Let's take a look at our systems. The system look kind of messy, but it's really not so complicated. It's quite simple. You've got pulleys and cables. All these pulleys will have friction. This one will have friction. And motor does not work. It's at 100% efficiency, so you have losses from there. So 85% efficiency is actually quite good in terms of a system's efficiency. So if you were to design anything, you need to find out what is the system's requirement. This is what's basically we're doing. We're finding out the system. The objective of this machine is to lift this box up at a speed of 0.6 meter per second. Is this correct? I don't think so. Crate C, okay, the motor lift 300 Newton crate C at an instant point P on the cable. Okay, has an acceleration of 1 and a velocity also. So this velocity is actually, if this velocity here, this will be slower. Is velocity here will be a 0.3 meter per second basically. Okay. Alright, so let's get some facts straight. Maybe you don't understand. So let's open up a new screen. Okay, let's remember first. Tension is 199, speed acceleration is 1.2 there, velocity there is 0.6. Okay, white screen. So this is the box. This box requires, it's like this, right? You have T here, now it becomes 2T. This box has pulleys, and this one is T, this one is T, which goes to the motor. So this is the motor. So this box is actually being lifted up by 2T. The box itself requires 2T in order to move up. This is mg, which is mg. This is the velocity of the box. So the data just now which was provided, they provide us this value, right? So allocation here, acceleration is 1.2, velocity currently is 0.6. So if the velocity here is 0.6, velocity here is going to be 0.3 meter per second. Yeah, meter per second lah. What else? Acceleration. Acceleration here will definitely be, if this is 1.2, this is actually 0.6 meter per second squared. So what do we want to know? Tension. Tension is 199 Newton. Tension is 199 Newton. 199 Newton. So power sama dengan force times velocity. Force is 199, velocity is how much? 0.6. Berapa is that? 199 times 0.6. 199 times 0.6. Okay lah. 119.4. 119.4 watt. Power here. Power where? Power here lah, I suppose. So this power is being transmitted to the bottom lah. What is the power at the bottom? Let's calculate. Power is equal to force times velocity. You might think, oh, this one is running slower, 0.3. 0.3, which is slower. But you have two tension. So 2 kali 199 je lah. 2 kali 199 Newton. So 2 tension. So 2 kali 199 kali 0.3. Berapa dapat? 119.4 watt. So same. Nothing is missing. Only thing is this one has one tension. Remember our pulleys? This is our pulley, right? Pulley here. I suppose we have a pulley here. So the good thing about pulleys is that it can double the force. 199 Newton boleh angkat barang yang double the weight because of the pulley. But there's nothing that's quite magical. Power is the same. It's how you use the power in your design, in your systems. Okay, so this is very important for you to understand. Okay, and that's it. Alright, so now let's take a look at something more simple, I suppose. This is way simpler than the previous one. Way simpler. It is all in. A motor hoists a 60 kilogram crate at a constant velocity. This is very key lah. This one weighs 60 kilo to a height of 5 meter in 2 seconds. The indicated power of the motor is 3.2 kilowatt. So, yeah, efficiency is equal to output power over input. Output power or input. Indicated power of the motor is 3.2 kilowatt. So what is this? Output or input? Indicated power of the motor 3.2. So obviously this is input. Output is always our system, how you design your system. Basically this is one pulley, one cable. So this one has tension, this one has tension also. This is 60 kilogram, this is going down mg. So that's how the free body diagram look like. If you really want to separate it, it's like this mg and t. It is moving at a constant velocity. Summation of forces is equal to ma. What happens here? If it's moving at a constant velocity, no acceleration lah. A is equal to 0. So what to do? Power is equal to force times velocity. So summation of forces is equal to ma. Let's do the equation first lah. Summation of forces is equal to may. It's traveling upwards. It's going up. So going up is a positive. So you got T minus mg is equal to, this one becomes 0, right? 0. So T is equal to mg. 60 kilo, 60 times 9.81. So this one becomes 60 kali 9.81. 588.6 Newton. This is the tension. This T is equal to this one lah. This one is 588.6. Velocity, you gotta solve this one. Height of 5 meter into second. V is equal to V naught plus AT. 5 meter into second. There's no displacement here. Tak ada S, so this one cannot be used. Which other formula? This one lah kot. S is equal to S naught plus V naught T plus half AT squared. Acceleration is 0. This is gone. This one. S minus S naught over T is equal to V. Lima bahagi 2. 2.5 meter per second. So this is the velocity. So power, 588.9 times 2.5. So what do you get? Times 2.5. 1471. 1471.5 Newton. This is what's required lah. Not Newton, right? It's watt. 1471. So now you can solve it. But you gotta make some more room. Where do we make some rooms? Let's do it here. So now input, you know, is actually 3200 watt. The output is 1471.5 watt. So efficiency is equivalent to 1471.5 divided by 3200, 0.46. 0.46. Yeah, or 46%. Efficiency is 46% for this whole system. For this whole system that you are designing, this one, you are only working at an efficiency of 46%. What? Horrible, right? So horrible efficiency. Okay, nasib baik betul. How about this one? This one looks quite simple. Efficiency. Yeah, only thing different is that you have these two cables. These two cables, you've got T and T. Yeah, it's quite interesting to do. Should you do this on your own? Let's take a look. There's so many things that you can do. I guess we'll do some. There is an explanation on how to do this. Summation Fy is equal to MAY. T is equal to, yeah, you will never be able to understand if you don't do it on your own. You gotta do it on your own, then you understand. You gotta think. Okay, so this thing weighs 50 kilo. Let's draw properly. Let's draw free body diagram to this side. Mg. This one is T. If the 50 kilogram load A is hoisted by the motor M so that the load has a constant velocity of 1.5, it travels at 1.5 meter per second. If this thing is travel at 1.5, the motor has to travel double. V here is actually 3 meter per second. Why? Because you have this pulley configured a double loop. It has to pull 2 times the length in order to pull this one go up. Ini. So you have 2. This one 1. So if the speed at this box is 1.5, the speed for the motor has to be doubled. Okay. So determine the power of the input of the motor which operate at the efficiency of 0.8. Efficiency again, let's write it down. Output over input is equal to 0.8. This is the motor's efficiency. Determine the power input of the motor which operates at efficiency 0.8. Actually, the efficiency should be the efficiency of the overall system, because you've got lots of losses on pulleys and such. Okay, what's our question just now? Determine the power input of the motor. So berat dia adalah 50 by 9.81. 490.5. 490.5 Newton. What is T? T is operating at, is it a constant speed? There you go, constant velocity. Remember just now that we have derived summation Fy is equal to MAY. The motor goes upward this way, so positive is this way. T minus mg now becomes 0 because Ay is equal to 0. Tension is equivalent to mg, so tension is also same lah, 490.5. So apa dia nak? So power required is force times velocity. 490.5, you have to multiply by the motor punya speed, which is 3. No. Kalau nak tengok dekat motor punya speed, macam ni lah pula. T, sini dah jadi 2T tau. Dia split jadi 2T. TT. This one is T. If this is T, this is actually half T ke? the force is correct in every sense. The tension here has been half star. It's actually, if this is T, this is actually half T. Half T. Half T. So depends. Do you want to analyze at the motor? Kalau nak analyze kat motor, you gotta use half T, half T. Kalau nak analyze dekat system, you can use T only. So this one you gotta decide. We have previously proven this one. Kalau nak if you want to solve here, solve here. So I choose to solve here. Okay, I'm gonna solve this one by looking at this one only. So the force I will be using T. Velocity, yeah, it's gonna be 1.5. So this one will be 490.5 times 1.5. $735.87. This is the power at this box. I don't have to care about the motor anymore. So this is the power at the... Okay, so let's take a look. What can we do here? Input, we don't know. But output is 7. Output is actually 735.8 over input. Input you don't know, but you know the efficiency is 0.8. This one you know. So you can find out lah. Power input is equivalent to 735.8 bahagi 0.8. So what do you get? 919.7 watt. This is the power input. Okay. Next question. You can do this on your own, but you got to really look at the system. You can ask yourself, do you want to analyze at the box? Or do you want to analyze at the motor? You got to decide. If you analyze at motor, solve everything. Solve the power is equal to force times velocity at the motor. If you want to solve at the box, which is the system that you are which is the load which is being moved. So this is what we call box. Let's give it a name, box also. So power dia kena ambil dekat force times velocity of the box. Yeah, you have to decide. You want to solve this one at the box, or do you want to solve top at the motor? In both cases, they are the same. They will work the same. But currently, all our info we are having at the motor lah. So if you have all your info at the motor, solve at motor. Okay. This one, yeah, slightly different. This one is interesting. Let's do this one. Yeah, we're gonna do this one. This one looks interesting. This is a 500 kilogram elevator. It weighs 500 kilogram. How many people can go in? 5 people can go in. Oh, it's carrying stuff starts from rest and travels upward with a constant acceleration of 2 meters per second. Don't forget your free body diagram. Don't forget it. When you have cables, cut them up. Cut them up, cut them up, cut them up. So I've got T, T, T. Tiga T. So this box has 3T. Going down is mg. So the tension at the motor is actually T only lah. Then it goes to the motor. Motor. Okay. Alright. So apa dia nak? 500 kg elevator starts from rest and travels upward with a constant acceleration. Okay, this has a acceleration equals 2 meter per second squared. So going up is positive. Determine the power output of the motor M when time is equal to 3 seconds. After 3 seconds, berapa dia punya motor power output? Oh, apparently power output So no efficiency given. So assume efficiency is equal to 1 lah. Determine the power output of the motor when time is equal to 3 seconds. Okay. V is equal to V naught plus AT. So velocity at time is equal to 3 seconds. Use this formula. It starts from rest. So V naught is equal to 0. 0 plus acceleration is 2 after 3 seconds. The acceleration, so velocity becomes 6 lah. 6 meter per second at time is equal to 3 seconds. So power is equal to force times velocity. So berapa force? Acceleration is 2 meter per second. So you got to solve this one first, Summation Fy is equal to MAY. Going up is a positive. So 3T. 3T minus mg is equal to MAY. 3T minus 500 by 9.81 is equal to 500 Acceleration is 2. So tension becomes 1000 minus 1000 plus 100 times 9.81 bahagi 3. So tension become 1968.3 Newton. This is the tension. What is the power? Tension T. Determine the power output of the motor M. So if you want to look at power output at the motor M, tension is definitely the same lah. This motor, look at the motor. This is the motor. So the tension you already find out, 1968. Velocity travels upward constant, so determine the power output of the motor M when time is equal to 3 seconds. So acceleration ni is actually acceleration of the lift, right? So this one is actually for the elevator ataupun lift or elevator punya velocity, not the motor's velocity. Kalau motor's velocity kita kena this is slower, so this is faster a bit lah. So kena 3 times. Okay, so anyway you look at it, it's the same, right? If you want to solve the motor, kena 3 times, lepas tu multiply by the velocity itself. 3 times the velocity, kalau tengok kat bawah pun sama je lah. So depends on you lah, where you want to solve. If you want to solve at the bottom, you gotta take 3t. You cannot take t. So let's try. Alright. So you guys can decide. Do you want to do it here? Or do you want to find the power at the motor? But one thing for sure, this velocity is definitely the velocity of the elevator, which means V at the elevator is equal to 6. V here is equal to 6 meter per second. V here would be how much? If this is 6, this is slower lah. Bottom here is 3 times slower. Here would have to be 18 meter per second velocity of the motor. So this motor has to work has to pull really hard lah, because it has to go to 3 pass, 1 pass, 2 pass, 3 pass. 3 pass baru lift ni naik atas. Padahal motor ni seorang dia je nak berfungsi. So the load is lower, which is 1968 Newton. Lower. The load is higher at the bottom. It's actually times 3 lah. Unit. Yeah, the tension that you need to pull, it's 3 times at the bottom. But so vice versa, it works the same. So let's say I want to do it at the bottom. Power is equal to force times velocity. This one would be equal to 3 times 1968 times the velocity, which is 6. Berapa jawapan? Times 18. 35424. 35424. 24 watt. Berapa? 35.4 kW. This is the power. What kind of power is this? Is it input power or output power? So input power is always going to be higher. Why? Because it has to cater for efficiency. You got to give more, and output power is the system's power lah. So this is definitely output power. Okay. What else? Okay, the rest of the problems you can try to do on your own. This is interesting also because it is slanted. As you know, mg will go down that way. You've got two components. mg is here. This is 30 degrees, or mg cos theta. This one will be mg sine theta. 30 degrees is your theta. 50 kilogram crate is hoisted up. Dia ada friction tak? Neglect friction. Senang je lah. Okay. So do this one. This one is good. Do this one. Alright.